So hello everyone again. So I will start with the classification of the mechanics that we have the mechanics that talks about the motion of objects. So the objects can be at rest. So it means that they are not moving, or they can move in uniform velocity, or they can accelerate. Okay. So this is what mechanics talks about. So it has two broad fields as solid mechanics and the fluid mechanics. The solid mechanics can talk about the rigid bodies, that what we will cover for this. This is our plan. And then it can also cover the deformable bodies. The deformable bodies we will not cover. So the for rigid bodies it is statics that talks about the at rest, or that it's talking about the equilibrium cases. And then we have the dynamics that talks about the kinematics and then kinetics. Kinematics just means that so the geometry of action, motion, the geometry of motion. So the object, for example, it moves from here to there. Okay, we just talk about the geometry, and it moves from here to there, and then you talk about the angle between the path and then the relation between these two paths. So you just talk about the geometry. You are using the geometrical relations, the trigonometry, and then etc. The kinetics is that we focus on the force. So what forces are acting on the body? So as we cover the chapters, you will see this these concepts more clearly. But as a start of example, I can say that so say that the car has the speed of 60 mph. Okay, and then the question is that the 1 hour, that after 1 hour the find the distance the car will travel. So it will be just 60 miles. 60 mph times 1 hour, it is 60 miles. So here we use just the we did not consider the forces acting on the car. We didn't consider the torque of the car. We did not consider the friction force between the car and the road. So what it means is that we did not consider anything about the kinetics of the particle. So, but if you consider the forces acting on the car, so this is the car, let's say. So if you consider the forces acting on the car, so like the wind force, drag force, and the friction force with the road, and then if you talk about the gravitational acceleration, and then this will be the kinetics of the body. And then coming to motion, so we have different types of motion. That will be a rectilinear constant velocity. Rectilinear means that the motion in straight line. And then it can be rectilinear with the acceleration. It can be rectilinear with acceleration but changing acceleration. So say that this one you are always moving with 60 mph, and here at uniform acceleration it is 60 and then 70 and then 80. So as time passes you increase the velocity of the car. The changing acceleration means that it was 60 and then you make it as 70 and then 75 and then back to 70 and then 80. So the acceleration is not constant. And this is the what the changing acceleration means. And then we have the curvilinear, and the curvilinear says that the curved path, and then it can be the circular and the general. The circular means that it's very clear that it moves in a circle. And general means that it can move this way, it can move that way, etc. and it can even be ellipse. Okay, so the types of motion, you can see this one is the straight line motion, and then you have the curvilinear motion and different types of the curvilinear motions, and then it can be closed to circle, and then you can see that we have different kinds of the motions, and then you have the different types of the acceleration here. It can be constant acceleration, it can be no acceleration like in the, so this one like in the cruise control mode. Okay, and then this is what the different types of motion we will talk about in dynamics. So in the dynamics, we will cover each of these motions for a particle case, for a rigid body case, and for a three-dimensional body case. The basic quantities that we will talk about is the length. So here it will be the distance, or it will be displacement. And then we will talk about time, and then mass. This will be for force, and then the force is acting on the body. The mass is related to force, and then we will talk about different types of the forces. Now let's start firstly with the particle. The particle is a that is imaginary, or you can say, or idealized concept. So it simplifies the problems. So what the particle means that it doesn't have a size, it doesn't have any shape, but it has mass. This is the meaning of a particle. So if I if you have a car, and then so the whole body moves as one point. So whole body moves like a point. Okay, it's not a point. The the, the car has dimensions, it has a shape, but we approximate this one as, let's say, not approximate, assume this one as a particle. And instead of a car, we say that this is a point. But this point has the mass of the car, and then, but it doesn't have the size and the shape of the car. This is the, but this is the, let me see, add it here. This will be the, we don't always consider the objects as a particle. We will look for the two-dimensional cases, we will look for three-dimensional cases, but as a beginning in the dynamics we will talk about the objects as a particle. So first, let me add it, first few chapters. So we'll say that the objects are like a particle. Okay. And then this one is a simple question, but it was planned to be a poll question. You can pause and then think you and find yourself. The question is that what is the derivative of 5t squared plus 3t? So this is just a simple question. So we have f of t is 5t squared plus 3, and then if you take the derivative of this function with respect to time, and then you will have that 10t plus 3. Okay. And then this is the answer. Then finally, so we have the gravitational acceleration that I will talk about in the next recording.